Question 4. A hemisphere is a solid revolution which can be obtained by rotating a quarter of a circle of x squared plus y squared equals a squared about the x-axis. And after this rotation, we'll have this hemisphere looking like this, with its center of mass somewhere on the x-axis. We know for sure that the y-coordinate of the center of mass is 0 due to the symmetry of the shape. To find the x-coordinate of the center of mass, we are going to use the expression, which is a fraction. At the top of this fraction, we have the integral from 0 to a multiplied by pi y integral of y squared x dx, and at the bottom of the fraction we have the volume of the shape. Now, to find the volume of the hemisphere, you can either use the expression for the volume of a whole sphere, which is given by 4/3 pi r cube, so we only need to halve it. Therefore, we'll have at the bottom of our fraction 2/3 pi a cube. Alternatively, you can work out the integral pi from 0 to a y squared dx, which is the integral to calculate the volume of the solid of revolution, and you will get exactly the same results, 2/3 pi a cube. Now, we have to work out the integral at the top of our fraction. Let's write it down separately. 0 to a y squared x dx. Y squared from the equation of the circle is given as a squared minus x squared multiplied by x dx. 0 to a, multiply out brackets and the integral to have a squared x minus x cube, all integrated with respect to x from 0 to a. So we have a squared x squared over 2 minus x to the 4 over 4. After substituting the limits 0 and a, the final expression is a to the 4 over 4. Let's put it at the top of our fraction. Don't forget to multiply by pi, so it's pi a to the 4 over 4. Now, after simplifying, cancelling by a cube, p is cancelled out as well. We have 3a over 8 as required. 3 goes to the top of this fraction, and 2 and 4 multiply together at the bottom. Part B. To answer part B, let's draw a diagram first. So we know the position of the center of mass now. It's distance 3a over 8 from the flat edge. We know the radius of the hemisphere is a, and it is suspended from the point on the edge of its flat face. So looking at this diagram, you can see that we have a triangle where the side of this triangle, AH, represents the vertical when the hemisphere is suspended from A. And we need to find angle theta in this triangle. Let's use the trigonometry. We can write down that tan theta equals 3a over 8 divided by a. So this ratio gives you the tan of angle theta, which is 3 over 8. And so theta is 20.6 degrees. to three significant figures.